Welcome back. What I'd like to do in this video is talk about the last application that I mentioned of time series models, which is around prescription. And this fits in very nicely with the regression that we've been doing with time series models. With prescription, we're really trying to understand how some other variable, such as advertising, impacts another variable that we care about, such as sales. Really what we're doing is we're talking about causality. So I'd like to talk a little bit about what it takes to have causality. So causality can be defined as a change in one variable will produce a change in another variable. So if I were to increase my advertising, then my sales would do something. Or if I would change the positioning of my brand, then my sales might do something. If you want to hear the whole lecture from my marketing research class, but we're going to do kind of an abbreviated version of that in this class. The first thing I'd like to just emphasize is that usually the best or strongest test of causality is going to come from a randomized controlled experiment, where I, the experimenter, can assign my sampling units at random to a treatment or control group. But this isn't always feasible. When it's not feasible, there are three different types of evidence that we use to infer causality. So the three types of evidence are concomitant variation, time order of occurrence, and eliminating other causal factors. What is concomitant variation? Well, the concomitant variation simply means that the cause goes with the effect. So when my when my advertising is high, then my sales are high. When my advertising is low, then my sales are low. That would suggest that my advertising level goes with my sales level, and that would be a necessary condition for causality. I mean, if my advertising had no relationship with sales, I couldn't really say that advertising was causing sales. The second condition is time order of occurrence. And so what this simply means is the cause must precede the effect. So I can't really say that advertising causes sales if my sales go up and then I change my advertising budget. I have to change an advertising budget and then see what happens to sales. The third condition, which is often the hardest to establish, is ruling out other possible explanations. What if whenever I changed my advertising, I also changed my price, and then something happened to sales? Well, is that change in sales due to what I'm doing to my advertising, or is it due to what I'm doing to my price, or is it a combination of both? So that makes inferring causality really difficult, and that's why it's really ideal when you can do a randomized controlled experiment. Then you don't have to worry so much about the other possible causal factors, but that's not always going to be possible. So what do we do? In market research, you probably talked about quasi-experimental designs. So these are experimental designs that have a lot of the properties of a randomized controlled experiment, and they allow us to rule out a lot of threats to internal validity, but they're short of having random assignment of sampling units to treatment conditions. So what is internal validity? Remember, internal validity is where if you observe some effect, so my sales have changed, and I think it's due to some cause that I have, like my advertising went up. Internal validity is when I can attribute the change in my outcome, so sales, to the change in my independent variable, in this case, advertising. Let me quickly go over two very relevant designs. So one is called the before-after with control quasi design. This is where I've got two groups of sampling units. One we're going to call the treatment group, the other one is the control group. And I take a pre-measure on both, then I do something, then I take a post-measure on both. So the way we're going to assess what is the effect of this treatment X is we'll compute the difference between the post and the pre-measure for the treatment group, and we'll do the same for the control group, and then compute the difference between those two. And so if the difference is positive, then I would conclude that this X has an effect. let me kind of build up some intuition for why this is such a good design. Let's just say, for example, I did not have a control group, but I've got a treatment group. So I take a measure, I do something, and then I take a post measure. Well, what if my pre-measure was 10 and my post measure was 15? The difference between these would be 15 minus 10, which is equal to 5. But the question is this 5 due to my treatment, in this case, say, changing my advertising level, or is it due to something else? So one of the things that we're most worried about is something called history. So history is when something else changes between the pre and the post measure. Suppose roughly at the same time when I changed my advertising level, the competitor also cut their advertising level. So the history part would be the competitor changing an advertising level. And maybe that actually has an effect of, say, +3. So because the competitor cut advertising, our sales went up. And it wasn't due to our advertising, it was due to what the competitor did to their advertising. Or maybe the competitor raised price at this point, in which case the effect of our advertising would really only be 2, yet we would falsely conclude that it was 5 because we don't have a control group. All right, well, let's go over to this stronger design. So the treatment group and the control group. And this is the design. And let's say we've got some history happening here. So we got a 10 and we have 15. And this is a +2. In the control group, maybe these stores also start out at 10, but because the competitor has cut price, we observe a 13 here. So then let's go compute the effect of the treatment. This would be the difference in the treatment group is 10 minus 15. The difference in the control group is 13 minus 10. This would be 5 minus 3, which is equal to the correct effect 2. By having this control group, we can mitigate the effects of history. So this is an important design when trying to establish causality. I'd like to give you a real example of this that I worked on in some of my work with the Spiegel Research Center. This comes from a study that I did with a PhD student at the time, Becky Wang and Lakshman Krishnamurti. And the question we had was, when somebody adopts a mobile shopping app, what happens to their subsequent purchase behavior? Do they all of a sudden become better customers? This is a very famous picture that's probably about 10 years old now. This happens to be in Korea, and it's in a subway station where this person is doing his shopping with his mobile phone. So the Tesco supermarket chain bought all of this billboard space between the doors in the subway, and while this guy's waiting for his subway, he can scan some QR codes, hit send, and a couple days later it'll appear in his doorstep. This is the local version of this. There was a grocery retailer here at the time called Peapod, and this happens to be at the Belmont L stop, where they tried to do the same thing. So we have data from the Peapod grocery chain, and we want to understand what effect will someone adopting this app have on their subsequent purchase behaviors. And by that, I mean purchase frequency as well as the basket size. So do I buy more because I can shop anywhere and anytime than I did before? This graph shows the key evidence in a very simple way. So what we're doing is we're looking at the order size, the average order size for both those who adopt the mobile app and those who don't, as well as the order rate. Let's start out with the top set of lines here. And so what we're going to see is the X's are the mobile shoppers, whereas the triangles are the people who did not adopt the mobile app. So that's our control group. And what you'll see is that the two means are right on top of each other. So that says prior to launching the mobile app campaign, these two groups were about the same in terms of their average order rate. if we look at what happens post-adoption, so in here we launch the mobile app, these people adopt the app, these people don't, it looks like the effect is flat for the mobile adopters. There's no real change in the mean order size in the post period versus the pre-period, but look what happens to the non-mobile adopters. Their average order rate actually goes down. If we were to take the difference in the treatment group, it'd be about 0, but the difference between the control group would actually be negative. And so this difference right here is the effect of the treatment. So this would be 0 minus whatever that negative number becomes a positive number. And so we would conclude that among these high spenders, adopting the app actually increased their order rate over the control group. If we look at what happened among low spenders, what we see is a similar story. The non-adopters are shown by the darker line, and that is roughly flat. Maybe it increases a little bit, but the square, the gray square, increases a lot more. So we would conclude that even among low spenders, the order rate increases due to adopting the mobile app. When we look at the order size, what I see is not a lot of difference between the mobile shoppers and the PC non-mobile app shoppers. Even though if we were to only look at mobile shoppers, it looks like there's an increase, the control group also increased. So there was a very small effect, if any, in the order size. The effect size is even smaller for the high spenders. And if we didn't have the control group, we would come to the false conclusion that mobile shoppers have a substantial increase when they don't. Okay, so the point I'm trying to make with all this is it's important to have that control group if you can, because you can rule out whatever else happened to these other customers, which is called history. The next experimental design that I want to mention is what we're studying in this class, which is a time series. But this is a very special time series because something happens in the middle of it. We take a series of measurements, then something happens, some intervention. This could be, for example, a competitor doing something. This could be you changing your positioning. This could be you increasing the ad spend, and you want to know what happens to your sales after that. This design is also sensitive to history, but having all of the observations on each side of this makes it a bit more robust to threats to internal validity. Let's look at an example. I call this the chewing gum example. So let's say that we manufacture some chewing gum that's very popular, and at some point we decide to launch a brand extension that is a diet version of our existing chewing gum. So the question is, what happens to the market share of our established brand after we launch this diet brand? Here's a couple scenarios where here's what happens until we launch this new brand. Then all of a sudden the market share of our established brand drops substantially, but then it goes right back up. And so this would signal that perhaps we temporarily cannibalized the market share of our existing brand with this diet brand, but there was no harm done because those who don't want the diet brand go back to the original one. In scenario 2, our market share is bouncing around a little bit, then it drops after the launch of the diet gum and remains low, and that's bad news for us. Scenario 3 is I see a downward trend and nothing really happens after the launch of the diet gum. It just continues to go down. So I would say the diet gum had no effect, although my dominant brand is in trouble because we're losing market share. Scenario 4 is where absolutely nothing happens. There are many alternative possibilities. I'm not going to be able to cover all of these in this class, but here are just some other pictures of what could happen, where maybe this is what happens. My market share drops, and then it creeps back up to my original level. Or it could be something like this, where it creeps back up but doesn't quite make it to the original level. It creeps up to a level that is lower than the original one. So this difference is the effect of the cannibalization. This is a topic that often goes under the heading of intervention analysis, which the author of your textbook mentions, but doesn't go into much detail on